Yep. So let's have a look. We have the curve y equals x squared plus 3x plus 5 and the line y equals x plus 8. Okay. A and B are the points of intersection on the curve and the line. Find A and B. That's part A. Okay. So actually this is exactly the same question as what we did over here. It's just over here we had to find A and B ourselves. Okay. And it didn't tell us to do that. Now it's actually explicitly saying, well, I'm going to give you marks for this. Okay. Can you find A and B first? Right. So let's do it. How do we find A and B? Tiffany, how do we find A and B? So we've got a curve, y equals x squared plus 3x plus 5. We've got the line y equals x plus 8. How do we find the intersection points of a curve and a line? York, how do we find the intersection points of a curve and a line? What do we do over here? How do we find the intersection points of a curve and a line? Tell me. I can't see it. Tell me. Right? So you mean to solve them simultaneously, we need to substitute this equation into this equation. Good. Okay, so to solve things simultaneously, to find the intersection points, people, it's not difficult. We solve them simultaneously, which usually means substitute one variable into the other. Okay? So we've got one equation here, let's just make a substitution. So okay, we've got x squared plus 3x plus 5. And we've got y equals x plus 8. So because we've got y's in both equations, I just need to make a substitution. Okay? What type of equation is this, York? Begins with a Q. A qua. What type of equation is it? Yeah, absolutely. Thank you, Megan. So, absolutely. So it's a quadratic equation. So because it's quadratic, what do we have to set it equal to? 0. Have to set it equal to 0, right? So we need to move these two things over on this side. Okay? So x squared plus 2x minus 3 equals 0. We can then try and factorise this. What do we factorise it to, Megan? Huh? What do we factorise it to? Good, so in other words, it factors to x plus 3x minus 1, which means that the roots are x equals negative 3 or x equals 1, okay? So therefore, we've found the x coordinates, negative 3 and 1, okay? But notice the question asks for the intersection points. So it's actually asking for a point now. Over here, we could get away with just the x coordinates because that's all we needed, okay? But if we want to find the points of intersection, we need a corresponding y as well.
Yeah, we put the x and the y equation.
Absolutely, good. So you've got the x coordinates, negative 3 and 1. So you just need to stick it in one of the two equations. Which one's easier, the x plus 8 or the x squared plus 3x plus 5? Absolutely, x plus 8. So if x equals negative 3, what must y be equal to?
5.
Good. If x equals 1, what must y be equal to?
9.
Perfect. So therefore, I know that point A, so point A is on the left, is going to be at negative 3, 5, and point B, which is on the right, is going to be at 1 and 9. Are you happy with that? Are there any questions, Batikon? Because you could see from the graph. Okay, so you're absolutely right. The way which I've drawn it, the grid, you can see that. But you've just assumed that the grid is worth 1. Every step in the grid is worth 1. It could be worth 5. Sorry? Yeah, so because you could see from the grid. Yeah, absolutely. Now, in the exam, you would not have a grid. Okay, so you wouldn't be able to do it, so you have to do it that way. Also, my point is, you've assumed that every step along the grid is worth 1. Could be worth 10, could be worth 100. I haven't given you the units along the bottom there, yeah? So yeah, you would have to do it this way, okay? Good, so let's have a look at part B. Part B says find the area of the shaded region. How are we going to do that?
Same as last time.
Exactly. So are you happy that I can speed this up now? I don't have to draw out each individual thing, okay? So it's going to be the area underneath the straight line. So it's going to be the integral between -3 and 1. Remember, it's always the one on the left and then the one on the right is on the top, okay? Of the line, which is x plus 8. Take away the area which is underneath, okay? The area which is underneath. So the area underneath is going to be the area of the curve underneath. So it's going to be the integral between -3 and 1 of x squared plus 3x plus 5. Okay? So it's always top curve, take away bottom curve. Make sense? Area of top curve, take away the area of the bottom curve. Okay? Always that way round. Okay? So we can do this then. So, all right, let's have a look. What would the area function of x plus 8 be?
What do you mean?
So integrate it.
Oh, it's be 1 over 2x squared plus 8x.
Good. Good, excellent. Take away. What's that thing?
1 over 3x squared power 3
Yeah,
plus 3 over 2x squared
yeah.
plus 5x plus c.
Perfect, plus c. Now here's a question for you. Okay, could you got away with subtracting these two things before you integrated? Yes, absolutely. Okay, it doesn't matter when you do the subtraction. Okay, I'm just going to do it at the end. Okay, but you can do it at the start if you wanted to, as well. Okay. Yeah, absolutely. So if you wanted to do it on this side, let me write it. Okay. What you could write is x plus 8 take away this function. So in other words, you would get, well, let's have a look. X take away x squared. So let's do this. So it's negative x squared.
Negative 2x.
Yeah, because it's x take away 3x, negative 2x. And then 8 take away 5.
3.
Yeah.
Oh,
So if you want to do it just in one, then it's just one function to integrate. That is also fine.
wouldn't that be easier?
Yeah, absolutely. So if you want to do it that way, that's fine as well.
The camera's working, right?
Yes. Don't worry. Okay. Yeah,
So you're gonna forget
good.
about this.
That's fine. That's fine. That's the reason why it's there. Okay. So yeah, and then you can just go through and do it from there. Okay. So I would say that that is probably slightly easier than this, but it's still the same idea. Okay. And then you just stick the relevant thing in. So let's have a look. So we could say half lots of 1 squared plus 8 times 1 plus c. Okay. Take away. So I'm just doing the first thing first. Take away.
15 over 2, negative 15 over 2.
Have you done it?
I think so in my mind, though.
Okay.
I'll do it in a second.
So that's the first bit done. Take away. Let me just switch colours so it's a little bit more clear. Let's do the second bit now. So it's going to be a third times by 1 cubed plus 3 over 2 times 1 squared plus 5 times 1 plus c. Okay. Take away a third times by negative 3 cubed. Oops. Plus 3 over 2 times by negative 3 squared plus 5 times by negative 3
Big equation.
plus c. It's a big equation, but the only reason why is because I didn't do it that way.
The first one is 28.
The whole thing.
Yeah.
Okay, 28.
This one says only do the rest.
Yeah, that's fine. Take away a bit in blue.
1 over 3.
Was it?
Not yet, I didn't do it yet.
Megan, have you done it?
Yeah.
Cool, what did you get?
Oh.
Take away 52 over 3, thank you. Don't worry, Archimedes, we've got it. 52 over 3. So what do we get as the final answer, somebody?
28 minus
32 over 3. Yay! So there you go. The area underneath this thing, or the area of the shaded region, is 32 over 3. Cool, well done. Make sense? Good, excellent.